afternoon, everybody. My name is Kütt. I'm the architect of the Estonian information system. And yes, that's a very fancy title, but it actually means very little because the actual handiwork is still executed at the specific agency providing services. But today I'm going to do what I still generally do, which is talk about things. I'm talking about E-residency, database, and the cloud today. But before we go there, get into actual details, let's talk about Estonia. This is a slide deck that I've used actually on almost every presentation I've had to foreigners, just to illustrate Estonia. The important number is this number. The data source I took the information from, I think it was World Bank, might be mistaken, actually rounds the population of countries to the nearest million. In the case of Estonia, this means that a quarter of our population is just around the That's how small we are. And we can see that we are like on par roughly with Latvia and Russian Federation way back in terms of GNI from US and Singapore. What's even more important is this figure. This shows us the trend of the GNI per capita. And Estonia, Latvia, Russian Federation, we are sort of back here. Sometimes we are ahead, sometimes Latvians, sometimes Russians, it doesn't matter. Difference is not that much. Gross national income, it's basically GDP, that's slightly different. Why it's different, it doesn't really matter. It means how rich we are, or how poor we are. And the point of this picture is that although we get richer, these figures get richer still. We're growing about, say, at the same pace. And even if we manage somehow to magically replicate the miracle of Singapore, where they actually grew much faster than everybody else, it will still take 10, 15, 20 years to catch up to the US and Singapore and South Korea and these people. This means that for the foreseeable future, we are, as the polite saying goes, resource constrained, which in Estonia just means poor. And that's how things are. So, how can we even possibly afford the country being so poor? And please remember that in these parts we need a really well-functioning country, because if we leave a gap anywhere, there's a chance that it's going to be used in some way or form. And you already know the answer. We go paperless. We have less bureaucrats, we have less papers being pushed around, and we also lack the feedback loop of bureaucracy, creating more bureaucracy. And at that point, at several conferences, somebody has gone, oh, but we need those programmers instead of bureaucrats now. And aren't those servers horribly expensive? And is there really a saving in this fancy garment? Well, yes. We are seeing use cases where adding a single feed to a single service on XRO, which is our integration process, effectively has a return on investment of 6 years. Not for that feed, but the entire XRO infrastructure. Adding one feed pays for the entire thing in 5 or 6 years, depending on how you do the math. Estonia spends, and people are paying that number, the order of magnitude is still right. Estonia spends 2 orders of magnitude less for IT than Finland. And for those not that familiar with the geography of the region, we are not 2 orders of magnitude smaller, either by area, either by order or population. So it actually really saves us money that can be spent elsewhere. The One other important number on the first slide is this. In 2013, apparently there was that many people in the Estonian workforce. And God forbid this one guy sort of breaks his arm or something. And to sincerely hope that he's doing well, otherwise they've done this one guy. What this number basically means is that our prime minister to citizen ratio is too high. We still need one prime minister. 700,000 people or 7 billion people, there's still going to be prime minister and government and parliament. You know, if you want to set up 24/7 monitoring, you need at least 4 people. It doesn't really matter whether the thing you're monitoring is that large or that large or that large. You still need 4 people. Which means in Estonia, our overhead is very, very large. Our fixed costs are relatively high compared to the variable costs if we consider this, the variation in the population growth. So, what can we do about it? If you are familiar with the Estonian psyche and the general being and the demographic trends in Estonia, then you will realize that forcing Estonians to have more children, that's not really an option. Also, inviting lots of different people over here is really not an option either, because quite frankly, who the hell would actually want to live here, other than badgers and squirrels? And basically, let's face it, Finland is right there. If somebody has already said, okay, so I'm willing to tolerate the code, it's much more likely that they end up in Finland or Sweden, where the planet is the same and the overall infrastructure is much better. So what can we do about this? And the answer is government as a service. That's basically what our concept of digital e-residency is about. Has anybody read the news about e-residency? Everybody knows what it is? Generally, people know. Yeah. In that case, I must actually ask you guys some questions afterwards, because I don't have a full understanding what the hell it is and what it is fully. But on the sort of outside, what it means is that we will be handing out ID cards to people, effectively, to anybody. I was at a seminar with very well-educated European researchers and policymakers, and they gave roughly the same presentation, telling them, yeah, you know, we're going to give out electronic ID cards, and yes, we will have this ambition of giving out 10 million of those. And people went there, wait a minute, just have 1 million people. Yes, but we sort of give them out to everyone. What do you mean? Like, me? Yes, of course. That concept is so alien. That idea that the country sort of pushes its founders to that extent is completely alien to everyone. It's so radical. And I think it illustrates very neatly the position we're in. I'm the e-residency skeptic. I'm one of the more skeptical people around e-residency. But I don't see really any other options. We are so tiny, we are so small that we need to innovate around what a country should use in order to actually remain a country. Very simply, it's a question of survival. And the alternatives, not playing around with e-residence and other things, those options are not much better. However, e-residence is something that is, yes, we need to sort of go and meddle with the personal ID codes of Estonians, and we need to do all those things, but that's not really interesting. What is interesting is that all of this dependency on each service means that this will continue to become a problem. And that's where the cloud team starts to come in. You see, we can't switch back to paper. First, obviously, because for the same reasons, we actually went digital in the first place. But also, we no longer have power. I didn't really realize this, that I've been working at this position for a year, and the more I learn about our information systems, business processes, and so on and so forth, I realized that there's absolutely no way back. Firstly, there are not enough people to actually process the papers physically. And secondly, the skill of managing mountains of paper has been lost over the past decade. Because simply it's not necessary. It's not needed. Therefore, that skill is lost. And therefore, we don't know how to manage papers. And the other thing is that digital is built very, very, very deep into the stones. And that's, again, where we differ massively from the rest of the Europe. The rest of the Europe takes their age-old process of doing something and then goes, oh, but we can send this paper over the internet. And they send those papers over the internet and automate the same silly process, converting it into very automated, very efficient silliness. But it's still kind of silly, pushing the paper around. Finns and Estonians, actually Finns are only guys who actually do it the same way. We actually redesigned the business processes around digital, meaning that we designed the processes from ground up to be electronic. And this is not because Estonia is some sort of magical internet Narnia where everybody's loves the internet. No, it's simply because we had the luxury of not having a legacy. And we had the luxury of designing the processes like so. But still, the fact remains we cannot go back. These processes we have built around our e-services, they no longer scale on paper. We can't actually make them work on paper. What this means is that really, as I said in the tip, digital continues really is a problem. So what can we do about this? Well, if you want to have a tier 1 data center, actually, if you want to have 2 tier 1 data centers, you need to place them 250 kilometers apart. There is not, you can't actually do that. Well, you can, but then one of them ends up either on the islands or close to a certain border. Neither of which is a really good idea. So, from one hand, we have this digital continuity problem, and from the other, we actually physically cannot build a proper data center infrastructure. And by the way, one of the points that those data centers need to be placed that business apart, at least, is that they belong to different sort of supply areas from the perspective of the power grid. In Estonia, if there's a massive accident in a certain power station in northeastern Estonia, the entire Estonia is going to be dark. It's going to be dark. Not because both of the data centers are going to be dark. So, what can we do? Let's move to the cloud. And now this is where our lengthy introduction actually turns into the actual presentation. Because we have thought about these things long and hard, and the thinking has materialized in a concept that is called data embassy. And we have run into several issues and challenges, and we're doing so. Those issues and challenges are the actual meat point of my presentation today. First thing is, I want to talk about is this Estonian infrastructure. Or this is actually my subject of my work. This is the Estonian information system architecture. We have the agent system, we have the layers. We have infrastructure layer, integration layer, that is the actual delivery channels, electronic ID, And what happens if we want to move this thing to a cloud? Which means, in this diagram, which means that part of that infrastructure, that chunk here, is going to be deployed separate. Let's say in our let's say, Beijing embassy, not really, but let's say Swedish embassy. What happens is that, all right, everybody goes, yeah, we have fairly high, the studies show that we have fairly high virtualization rates. Very large number of Estonian government IT servers are actually virtualized. So let's take that. This image we just deployed in a machine in an embassy and get on with it. We have the state embassy on Victoria. The question arises, what about network? What about network configuration? So what nodes does that node actually need to see and why? What nodes must be hidden? How does the network look like? All right, so now we need to start replicating network settings as well. And oh darn, yes, your service kind of depends on the X row, asking questions from different registers. So does your service actually survive being cut off from the X row? Because that kind of depends on the other registers, and those other registers might be still in Estonia. So how do you do that? Deliver examples. Now that's where things get really interesting. If you think about a problem of DNS, that for the vast majority of the time, your service must resolve to IP address in Estonia. But at a click of a switch, you must be able to actually switch it over to point to a different main server. Not in Estonia. It is really a non-trivial problem if you think about it properly, because you will find out that a lot of the DNS servers Estonians depend upon are not actually in Estonia. So if Estonia is, for example, cut off from the rest of the world, you will create interesting situations where half of the world must resolve to the new data embassy IP, but the Estonians still needing the service must still be able to access the local version. And then you get the issue of actually merging those back later. And the question becomes really obvious. And of course, electronic ID, our certification center is very nice that it's located in Estonia. If we have this service that is only accessible via your ID card, and we can't verify your certificate or creation list because the plastic list is in Estonia, then, well, yeah, well. The point is that the cloud is not simply an infrastructure problem. It simply isn't. Very, very rapidly, you get into, all right, so infrastructure we have deployed, you get into network, you get into integration, you get into delivery channel issues, and it becomes very rapidly also a business process issue. Because you see, that stack, that cutting off, actually continues outwards. And you need to be able to cut off the business processes as well. By the way, data embassy or virtualization of the country, we have actually done before. In 1940, that's exactly what happened. However, that was 1940. Now it's 2014. Is it really possible to cut off a business process in a way that is actually independent and can be executed outside of the scope? Is it? I don't know. I'm not a specialist. Some processes probably can, but no, it's not everything. So, the question about cloud becomes a sort of very, very complex problem for everybody in an organization. And it turns out that in the cloud, it's relatively straightforward. The previous presentation described us that you can actually do that. Everybody does it. Transfer-wise does that all the time. Being outside of the cloud is also very doable. Everybody knows how to do that. But actually shifting between those paradigms, that's where things require a really high level of maturity from everybody in the organization. I'm not entirely sure that all government agencies actually have that maturity. That's a challenge for us. The next issue that we have is the question of trust. Whom can you trust? The next couple of slides I can almost skip because the point was very nicely and very neatly illustrated by our friends at Microsoft. yesterday. Anybody know what happened to Azure yesterday? There was an outage. 9 hours of an outage. Global outage. Let's imagine we had deployed Estonia into Azure. 9 hours, no country. Oops. For business, yeah, you lose business, but you can always, hopefully, somehow have Azure or Microsoft pay for that. Microsoft keeping on pockets that they actually will. With a country, there's this thing. We have this thing that's called electronic government. Well, basically, it's an electronic body of laws, and we have basically gotten rid of the paper version. That means that if that registry is down, there is no legal law in Estonia. Not simply just because there is no way to verify whether some action is legal or not. For 9 hours, I'm not entirely sure that the implications of that would be very nice from legal perspective. And the thing is that small cloud players are too small. Yeah. So you give your servers to some cloud provider and they go bankrupt the next day, or pilot, or decide to get out of the business. Then what? Yes, you can sue the damages. Yes, but what about the country? Will they be able to live up to the collateral? Then there's this awkward issue of you having, let's take a company A in Estonia, and let's say we give all of our servers to hosted by that company. And within a couple of weeks, we find out that the parent company is bought out by the parent company of a guy that is friends with the owners of Gazprom. Oops. Our risks simply increased. Like that, and that's completely beyond our control, because the owners of that company are very welcome to do business with whomever you wish. The big players, however, are too big. We go and tell Microsoft, yes, we'd love to have these 200 virtual servers, please. And we would also like to dictate to the conditions under which you will provide us the service. That's not how it works. That's not how any of it works. Yes, they are interested in us, but they're only interested in us because our thinking can be used to actually sell their services to bigger governments. That's it. We have absolutely zero leverage against Microsoft or Amazon or whoever. And they can decide to get out of that business like that. There's this race in the bottom in storage wars. Might happen in the cloud. All of these things can happen. And, by the way, what about democratic change? Let's say we have friends. Let's say we are friends with, I don't know, Botswana. And we store our servers and our data in Botswana because we are friends with the government of Botswana. And then there's a completely and utterly democratic process through which the citizens of Botswana decide that their government has the absolute right to look into all data under their jurisdiction. And they will do that. So, what is Estonia to do then? I mean, we might think this is wrong, but the people of Botswana have spoken. And they have the right to do that. And the company must actually comply with those laws. And by the way, with great multinational companies, it is not really entirely clear what is the jurisdiction they fall under. It's not clear at all who has actually the right to actually claim certain servers. And, you know, what this all comes down to is this. This is from the awesome movie, Rolling. That's Robert De Niro. There's a great quote from the guy here. Lady, I never walk into a place I don't know how to walk out of. You better have a place plan in place for what happens if your cloud provider fails your trust. Because they can do it instantly. You need to have backup. You need to be able to get out in a hurry. You need to know how to walk out of that place. Because in the end, nobody can be trusted. That's the simple step. Not with really important things. Yes, it's always a question of what is your risk profile and what kind of data you're storing and what business are you in. But with really important stuff, you simply cannot trust anybody, not if you're a student. You remember that slide? Small guy underneath. So, what can we do? And the answer is cryptography. There's something that's called secure multi-party computation, which is really awesome concept. What this allows you to do is it allows you to share data between parties and perform computation on top of that data in a fashion that the parties actually can't access your data. Let's take an example. Let's say you have US and you have China. Both of them have satellites in orbit, right? Both of them are interested in not colliding with satellites, having the satellites not collide, but neither is willing to trust the other party with the exact coordinates of their satellites, right? So, in the context of secure multi-party computation, what you can do is you can submit both trajectories of US and China between three parties, and ask questions from that cluster about the trajectories. And it is mathematically provable that you cannot deduct the trajectories of the satellites from the answers you get. And none of the parties actually can compile the trajectories either. It's very straightforward and very simple. Let's try to illustrate it. And by the way, all of my knowledge of this awesome technology is based on these people. Share my team. It's a startup company, and they have actually figured out how to do this and how to make it scale. And basically, this is how it works. Of course, there's a lot more math behind it, but that's the basics. Let's take two numbers, 12 and 8, and their average is 10. Now, let's split both of those numbers in between three nodes. 1, 4, 7, and 3, 2, and 3. And now you can ask, node 1 for the average of these numbers. You get 2, node 2 you get 3, node 3 you get 5. You add those numbers up, you get 10. Node 1, node 2, and node 3 have no understanding of what the actual original numbers were. And I have no way of knowing what the original was either. I just get the average of it. That's basically how it works. Of course, there's a ton of nitty-gritty, both computer science, engineering, and mathematics behind it to actually make it work. But this is one of the technologies that we are looking into in order to make the data residency work.
But if Gazprom will buy ShareMine?
Well, that's the beauty of it. It's cryptography. Gazprom can buy ShareMine, but when that happens, we still have the source code is still open. We still know what goes on underneath, and we still know the algorithm by which the numbers are split. What happens if a Russian scientist figures out how to actually reverse engineer that thing? That's a different story. But based on our current understanding of the math, that's not necessarily possible unless there are any implementation mistakes on it. So that's one of the things we are trying to do. And you can see how this can be applied. You can do different. You can split the encryption process itself between parties. You can split the keys. You can split encrypted backups. You can split the entire application between different parties and have a UI actually ask questions of it. You can do all those different things if you're looking into using that technology. Second thing or the second way we use cryptography is browser-based cryptography. Basic logic behind the scenes that since nobody can be trusted, not a single byte of unencrypted information can move through an unencrypted device or untrusted device. Effectively, only leaving the end user workstation as being, to an extent, trusted. Effectively, this sort of brings us back full circle to the time of patent clients. With the difference that now we have a deployment vehicle. We can deploy those clients via the web, and we can use them in a unified way. The browser will need to build different applications, different platforms. And in theory, it is doable. It is doable. People run all sorts of funky things in JavaScript nowadays. The JavaScript world has taken great strides. However, there's still a challenge. Firstly, the standardization is still simply not there. The web crypto API is coming to age. It is starting to gain traction, but it's clearly that it lacks certain functions that we actually need. For example, it doesn't provide an API to actually interact with the token device, like a chip card. Can't actually. It's simply not there. Also, big players are really reluctant to cooperate on the browser and OS issue. Anybody here use Macros Yosemite? Anybody try to use the ID card software on it? Yeah, well, it didn't work. And Estonia was not the only country who was impacted. The US Department of Defense was weeks and weeks and weeks after Yosemite came out. They still hadn't got their software to work, and they have ID cards out. So we have that challenge. And also, there are certain interesting computer science issues. For example, so let's say we encrypt everything and we send it to the server in an encrypted format. How do you do search? You want to do search over all documents. You don't want to pull the index out to the client to search there. It's too expensive, but the data is encrypted. So how do you solve that? Yes, we can extract the keywords and then do search based on those, but then we read the keywords to the cloud. Can we actually do that? Certain data, yes. With some other data, no. How do you actually solve that? And then there's key management. Let's say I have encrypted all of my important documents with my awesome ID card. I carry it with me everywhere, and then I lose it. I don't have a good solution how to actually do that. Maybe surrogate keys which you can access via with your ID card or identification, but then again you need to have a place where those surrogate keys are kept. And what if that gets compromised? Lots of difficult questions. But my goal today is not to provide an answer. I didn't say that in any point in the presentation that I'm going to tell you how we're going to do the members. I only told you that I'm going to talk about challenges that we have faced. Challenges that most likely are challenges that are being faced by any organization trying to move to the cloud. So let's draw some conclusions. What can we make of it all? Firstly, as I said, moving to cloud assumes a high level of maturity from the organization. Actually, much more than either being out or being in. Shifting between those paradigms is really complex. And it assumes that the entire organization, from the business to the system administrator, can actually relate and is willing to cooperate and is willing to think and change. That's really the sole goal. Trust decisions need to get implicit. Because we make a lot of assumptions about what can be trusted. How much do you trust your CPU? Do you really trust your CPU? Ends up if you trust CPU in your laptop. Why is that? That bloody thing contains billions of transistors, and it only takes like 2 or 3 modifications of those transistors to actually alter the behavior in a way that would be A, disastrous, and B, completely undetectable. Why? Why do you trust that CPU? Do you trust your network interface? Do you trust your operating system? Do you trust? See, you make a lot of implicit trust issues every single day. However, if you go to cloud, you absolutely must ask those questions explicitly. It's an incorrect explicitly. Because on the cloud, lots of questions arise like that. Lots of questions about trust. Cryptography seems to be the solution. Like alcohol. Technically, alcohol is a solution. From chemical. And cryptography seems to be a way to actually approach this. And like with ShareMind, we have some ideas of how to do that. However, it is not entirely clear. We're trying to do stuff that is not sort of fully there at all. There are the initiatives to actually how to build really secure government cloud is still just springing up. Germans are driving an initiative. We're trying to be partners of. US is doing their own thing. So we're really on cutting edge, and really there are answers. However, if you are a business and if you even have the function of risk management somewhere in that organization, and eventually you will, then the questions we are asking ourselves now are the questions we will be asking ourselves in the future regarding the cloud. The answers might be different, but the questions, I'm pretty convinced, will be the same. Thank you. Any questions?
One thing came to my mind if we talked about basically the risks. So, is there anybody from part-time? I know how the part-time, I really like how they are solving their risks. For example, they are basically making the timestamp. And they are printing every month in Financial Times, they are hashed there. So with that hash, even if everything, all the computers are gone from the world and part-time is gone from the world, still you can verify with one month's exactness, is it your signature before that hash or after. So it's a kind of idea that maybe there is a solution that we shouldn't put to one cloud everything. Maybe we should put, for example, I don't know, 1/3 of our people's data to one cloud, the second one to the other one. So if one is compromised, and even if the worst case will happen, then only a part of our nation is compromised.
That's wrong in the other part. We can, like, that's not there anyway. So you're right. That's big. Is something that we're trying to do with ShareMind. However, having that hash on the paper also assumes that there is ability to actually use that hash and do that math manually.
It probably can be done.
It probably can be done, but I'm willing to bet there are very few people around the world who are willing to actually go there, actually able to stop from their hearts. Remember, no computers ever. Like there is no computer you can actually look stuff up from.
Let's say that part-time doesn't, the infrastructure doesn't exist anymore.
Yeah. So you need to calculate these things manually, and then you do a calculation error, and your calculation ratio is just gone because you just calculated some key for it. Again, I don't have the answer, but we are thinking about this.
Having the second, third time together discussing about this data accuracy, when you are saying that there are piece by piece everything you cannot trust. You cannot trust the server routes by the clouds and so forth. And then this idea that let's use the space of our embassies, physical embassies in other countries. Let's say this is our land in Japan or whatever. But if you cannot trust the land there anymore, because things change, Japanese are not our friends anymore. Let's say it might happen. So wouldn't it be actually making a place that there wouldn't be any chain where you actually have certain things that you can trust without any risk?
Well, it's always a question about risk management. It's always the question about how much are we willing to spend theoretically on certain risk, and what is the impact of that risk materializing. So there's always that risk management, and I don't know. It is a question for other people to assess the risks, but so I don't know what can be trusted to what extent. Fundamentally, everything can be challenged. That is, fundamentally, all trust can be challenged.
For example, this is Sherman. Let's assume you all set up 3 nodes. They are physically separated locations. That's fine. One of them are now out. You don't have it anymore. So what will you do then? Then you will say, oh, we need to have some backup. So the data that was in the 3rd node, now gone, should be somewhere else as well. So still, and then the problem rises and rises. So it would be really interesting to see how you solve that actually.
With encryption, and the point of SharePoint is that, and by the way, with the services data moved to our physical embassies, we still assume that that's hosted by ground. Stuff there is always encrypted, regardless. But with SharePoint, that's the awesome part. You can actually split it up in so multiple ways that even if one node is compromised, you can still rebuild the data. And compromising that one node means nothing about the entire global data.
But anyway, it's a very interesting topic that to see how we actually solve that. So
yeah,
sure.
Really, let's do it.
Yeah, we are actually doing it.
How far off is it right now? When will it be ready? Is there some kind of timeline?
That's right. I don't know. And I don't know because I don't need to know. And all of the stuff is actually around the data embassy and E-residency as well. It's actually sort of under red standard, not a public discussion. But for the E-residency on 1st of December, first cards will be issued, so it's actually specific basically. It's not just ideas, it's specific action.
So yeah, of handing out 10,000 ID cards from Estonian government. Was this some
10 million.
10 million, sorry. Was this someone's wild idea, or is it a reality that is going to happen eventually?
Everything starts out as a wild idea.
And progress at the end.
1st of December will show. With technology, 2 things are known. Is that people overestimate the rate of growth and underestimate the impact. When the ID card was introduced, it was sort of said, oh, that's a really bloody expensive ice scraper I have on my card. Even for that, it's really useless. Now, we get like 44 million digital signatures a year from conversations. It's kind of useful now. And that's the thing with innovation. You never know. It might be a complete talk. Nothing happens, nobody's interested, we get the initial buzz and that's that. We might also get 10 million people, and by the way, 10 million people means that there are tens of thousands of people in every developed country that will be personally hurt when Estonia disappears from the map. That's a really neat thing to have. There's one final question.
Yeah, final one. That's a tricky one. I would ask in a way that if you reply and you cannot reply, you will be more silence for more than 2 seconds, then I would say that's the yes. So my question is that have you been approached by NSA and that kind of security interest areas? Because as one of the speculation for this E-residency is point-to-point cryptography use. That is not so good thing for big eyes.
Of course, all sorts of agencies immediately. But the news started leaking, and our people were in the US, and they were approached immediately by all sorts of agencies. The main concern was about taxes, and to say like the taxes was the first question, because now there's a big fear that all sorts of FATCA and know your customer and other rules that are being imposed that are actually protecting German, US, France, taxpayers. That their fear was that Estonia is going to become a tax haven, basically. We tried not to do that. We tried to even avoid communicating about that. And that sort of illustrates the entire interest towards the E-residency. Of course, there's immediate interest from all sorts of different parties. But think of it like telecoms and Skype. To this day, telecoms and telecom regulators have no idea what Skype is and how to regulate that. There's widely different sort of setups and how to think about that. E-residency is kind of like that. It's completely different. It's like it's out there. It's awkward. It doesn't really shift paradigms.
There's a difference that Skype is a corporate company. You go there, you agree that there's a backdoor. But with the government,
you go there, you agree there's backdoor.
But anyway, I agree that there's even the wrong there's a business case, definitely. A lot of people are looking for point-to-point cryptography on the cards. And when you lost the card, it's then closed. You cannot open the documents anymore. So I support it, but maybe it will not be exactly on the services that are providing some other things.
I don't know. That's the thing about innovation. You really never know how it's going to be picked up or what it's going to be used. And that's one of the risks we have actually identified is that first thing it's going to be picked up for is all sorts of shady activities. And we, for some reason, might lack the ability to actually shut those down in time. In which case we'll be we'll get sort of the status of Delaware. And well, imagine not being able to rent a car anywhere in the world because you're from Estonia and Estonians fundamentally cannot be trusted. That would be bad, right? We try to avoid that, and that's one of the risks. But now we all the time making questions.